So I'm Douglas Fallstrom, VP of Products. Get that part out of the way. I actually remember this time. The 2.0 it's a big release for us. What's interesting with the way we've chosen to develop our products is that we don't go like I did in my old traditional, that was a long time with Veritas Symantec. I keep developing for 9 to 18 to 36 months, and then I have this big bang release. Obviously, the time frames wouldn't work for a startup, but also we've chosen to do much more agile, very agile delivery methods. So we deliver, generally, I'm going to say 1 to 2 releases per quarter to customers. So you ask how fast to get features out. It kind of depends on the complexity of the feature always. That's the obvious kind of crux of the problem. But we try to be very agile on when we can deliver it. So if we have long-term projects, we have big things we work on for longer periods of time, because there's some features that just takes a long time to build. There are other things where you say, this is not important this quarter. I'm going to postpone this particular piece, even though we might have been halfway through it. I'm going to focus on this one customer has to come in, and it's going to get us some short-term revenue. So what you see here is, some things we might have mentioned before, maybe not on this slide particularly, but it's the accumulation we've done for the last 9 months. Remember, we went GA back in September, or first week of September last year, when we announced our 1.0. We've done 1.1, 1.2, 1.3, a couple update releases in between. We're doing 2.0 now very, very, very soon. It's accumulation of all this, and a lot of it is enterprise readiness. I'm going to spend a fair amount of time talking about what we do to the cloud. I'm not a big believer to just move old data to the cloud. I think the user needs a lot of flexibility, and we'll talk about how we provide that flexibility. Windows is 80-90% of the data center, yet we keep talking about Windows and NFS, Linux and NFS for us. We spent 9 months developing our SMB support and all the complexities between mapping users between domains. These are things that the big guys do, where they have multiple domains. If I'm logged in using, let's say, my East domain, I'm using data that someone from the West domain has created. How do you correlate the permissions across these? And we can do that now. So it's a huge amount of work that's gone into that, because it's incredibly complicated. Same thing with Windows ACLs. How do you map a Windows ACL over to an NFS v3 permission bucket? It's not straightforward. Yeah, read write maybe one, but usually you do a lot more complicated ones than that, especially on the Windows side.
Are you able to offer separate Active Directory domains for every file share, for example? Or?
Not today, not yet. So right now it's one AD domain. You can have different forests you can synchronize to, and you can have multiple mappings between different ones.
Through trust?
As a trust, yes.
Right, okay.
We'll talk about assimilation, how you use existing storage. It's not the Borg, but it's close to it. At least that's the way we like to think about it. And how we use the Snapshot Archival and the Snapshot backup enhancements, and how that can help and change the way you manage data. Whether data is live or it's a copy, it's still a piece of data you need to manage. So we offer ways to doing that as well. We've done a lot of work with networking. It's probably the most, I'm going to say, boring piece of a product, because you just have to do a ton of work supporting every possible nuance. But it's the most important one, because the moment you don't connect to a customer's network, you're useless. So we did a fair amount of trial runs early on with customers. We know what we need to do, and we can do even things like IPv6, which even a bunch of mature storage systems today cannot do effectively. I'm going to talk about expressions, something we're announcing with 2.0 as the next generation of our objectives. And I'll speak to resilience a bit now. So we covered resilience earlier. We talked about how the portal has an HA built in, automatically configured. We talked about this HA in the DataSphere itself. We also offer backup and restore of the DataSphere metadata. So you can run as frequent as you practically want it. It's an incremental backup every time. So it's not that it copies everything every time. And so you run this on the metadata server, copy that off the metadata server, preferably, do location outside. So the use case for this backup is very simple. If the metadata server for some reason burns up, you put them in the same rack, you're screwed up, and your storage is intact, but you have no idea what's what. You're not going to use your backup to restore to whatever the latest point of back time was.
So as far as, speaking of backup, as far as the data backup is concerned, that's all done by whatever services they currently have?
Absolutely.
And it's on a storage unit level or whatever the backup provider provides?
Right. Generally for NFS, they would usually mount an NFS mount point. We are working on things like NDMP once we get more customer requests for it, because that's a common way of extracting data from a filer, for example. But they will back up through our namespace. Like the backup server will mount our exports, not the underlying directly. If they want to get maximum performance, install NFS v4 client on a backup server, use a later Red Hat version, and you get it naturally. So you'll be sucking the data directly from the underlying storage out to whatever backup infrastructure you may have. What we've seen is what's very interesting is that customers are looking for us, and this is not news for you guys, people have used snapshots as a kind of quick recovery method for their data for a long period of time. The ability of storing those snapshots outside of your current storage, so they don't take up space of, let's say, your old flash fast for that matter, allows them to keep many more revisions on it and changes the way they think a little bit about backups. Doesn't mean you shouldn't do them, absolutely. I do backups the way you like them and comfortable doing it. But when you can lower the cost of a snapshot and make sure it doesn't impact capacity management of your primary storage, it's a little bit interesting.
And when you say assimilation, it's when you actually incorporate a new storage element into the DataSphere environment.
I'll cover that on a slide, how exactly we go through that. Yes, that's exactly existing storage.
Assimilator done.
And so you don't do replication yet, right?
Correct. We don't replicate data, but we can store data in a replicated data store, like a cloud bucket, for example.
Yeah, I'm just thinking of how often you run into issues with enterprise customers, like how do I replicate this to a secondary DR site, things like that.
So the ones that's one of the items on my roadmap is to support DR.
Yeah.
As in, everything burns on one, I'll spin up a DataSphere on the other side, and I can do it. Today, it's a manual process. You take your backup and restore, you point it to your replicated copy of your data, and you can do it's a manual process. We're working to get that fully automated.
Could you do array side replication and then do a restore of the metadata on the other side?
Theoretically, and that's what we're working on to see if that's
Yeah,
the
the
best way to
question is your product going to be aware of a different kind of snap? of
So the
replication?
snapshots are controlled by us.
Well, that's right.
So our snapshots are presented in the .snapshot directory.
You're taking the files that were snapshotted and not an actual block level hardware.
Correct. So it depends on underlying storage. So remember, we call into the file cloning API,
Right.
and many of those, let's say NetApp and ISO, for example, they do bitmap level copies underneath the hood.
But they expose another file in the snapshot.
Exactly. It looks like another file. It doesn't take up any space until you modify it.
Exactly. Okay.
So we take advantage of the underlying capabilities without having to build it ourselves.
But it's not strictly dependent. So when you're talking about that idea of replicating from one to another, the fact that it's not the same low-end bitmap, I can import the snapshots because they're just copies of the files.
And that
Okay.
gets interesting once you start doing the snapshot backup, where hey, the actual modified bits are not on my source array; they're on another storage, let's say a
Exactly.
cloud destination, right? And now you're like, okay, I'm doing CD to .snapshot. I see my, let's say if you do it on a date basis, I'll see all my backups, and I go into one from 3 weeks back because I know that's when I deleted my file, and it just copies it back from the cloud. You just copy the file to wherever you want it.
But it's just a file at that stage.
Exactly,
Okay.
from the user perspective.
Exactly.
And we support file cloning and file snapshots too. I should just mention that, not just direct, share level snapshot. The cloud, really important to us. We saw this picture, a similar one earlier. Some solutions decide to use things like A time, M time, and maybe C time, rarely, to move things to the cloud. Because we track activity to file, A time is not reliable. It's not always updated. M time generally always is a pretty reliable stat to use. But we also track what we call last open time. So last time someone actually used the file. Doesn't mean that any attributes were updated on the file itself. So you can look at, when you look at the activity slider for us in our UI, that's the last time someone used a file of some sort. Maybe it's read-only access and so forth. So that's one vector of doing it. You can also do things like, I want to move anything that's been modified or written to X time ago to this cloud. And then you can say, I want to bring it back and I want to move to another cloud. So that the cold to sub-freezing is absolutely doable. What's important is that we do this on a per file basis. So you can, and I'll show you, you can change the rule on this one file because I want to treat it differently than everything else in my directory or everything else in my entire share, or my global namespace for that matter. You can have one policy or objective that applies to everything. Right? It all depends how broad you want to manage it. And we don't think one size fits all. So you can do different objectives, say only files that are larger than 64 megs should go in the cloud, for example. Maybe you have some limits like that, or you don't want to put any small stuff out there because it's not worth it. Maybe you just want to put any files that belong in a snapshot that's older than X amount of time. So there's a lot of flexibility in the system, and you can do all these objectives and apply them at the file granular level. And that's the big difference between us and many other systems in the world. When we move things into the cloud, we mentioned this earlier, it's worth repeating. S3 compatible storage, on-prem, off-prem, I don't care. It's S3, it works 99% of the time. If it doesn't work, we'll make it work. It's that simple. We haven't run across an S3 that doesn't work yet, right? We automatically move things back. So an objective doesn't just go one way, it automatically goes the other way. So you don't have to define a policy that says, hey, when you access something in the cloud, go back. No, the policy is already defined. You say, when things are hot, they go on this type of storage. If it moved out into the cloud and there's been 2-3 tiers in between, we'll just move back to the tier 2 storage because it's now hot again. Right? So it's automated. We automatically do storage reduction with things to move to the cloud. We assume it's a remote point. So we do data deduplication, we do compression on the data. So if things move out and someone reads it, it comes back in and then it goes back out again, they're not transferring anything at that point because the bits are already in the cloud. We actually leave the bits in the cloud intentionally for that reason, so we don't have to transfer things back because it's probably cheaper to store things in the cloud than to keep doing that transfer all the time. The dedupe is variable block size. It's pretty efficient. I mean, you asked earlier whether we create one object per file in the cloud, and we don't do that at all. So we chunk the data before we send it out to the cloud. So we don't need to worry about large file transfers into the cloud. Everything is chunked, generally less than 128K, so it's relatively expedient to transfer them into the cloud. The movers are parallel, so you can have one cloud destination, what we think of as a bucket, and you can have as many movers as you want, and they all can move different files at the same time. Or you can have one mover and multiple cloud destinations, or you can do a combination of their own. It's completely up to what the customer would like to use. The system is very flexible. And obviously everything, we don't encrypt the data, but everything we transfer over a wire is HTTPS once it starts going to a cloud destination.
And the dedupe tables, because you said data movers are stateless, so normally I can spin up one too many. The dedupe tables, they're stored internally on the metadata server? Or?
Structured the naming and the signatures and so forth, and we're able to leverage the cloud destination to figure out if the signature is already, a hash range is already up there.
Okay.
That's changing a little bit because since everybody is also using local hybrid or local cloud, there's some optimizations we're working on right now that you'll see probably in about a month and a half, that we might be sharing more information locally rather than speaking to the cloud all the time. Like, hey, do you have that hash?
So it's not like every time I spin up the data mover, he has to suck down the whole hash table. Okay.
And this is an area where we're continuing to get customer feedback, and we like to rev our intelligence along the way. The Windows, SMB 2.1 and 3.x, it should work in most Windows environments we tested. Back to Windows XP and later, it's most shouldn't use that, but surprisingly many do. So we felt compelled to test. AD is fully supported from Windows 2012 and later. And as I said, it's one AD domain. You can do the trust and so forth. We spoke about already. Windows ACL is also fully supported. You can configure them. You can set them on your Windows client. You can set them in such a way that a user that doesn't have the right ID mapping on the Windows side won't be able to read them from the Linux side and so forth. So that the cross protocol work has been done to be able to support the intermix. What's cool with our approach is that you don't set this when you define the share. This is an export attribute for us. So you can say when you create a share, you say I want this share only on NFS. And you're like, oh no, I screwed up. I need to have the share on NFS and SMB, let's say 3 months later. And you can do that as well. You just go back and add SMB as an export. We support, anybody know what RFC 2307 is in this room?
That's what I'm looking at right now.
All right.
It's a good read.
It's a good read. Only a few customers come with that ask, and all those customers are very, very, very large because they care about that particular standard. Think of it as an ID mapping standard. We fully support RFC 2307 BIS. It's a big ton of work, and it's well worth it because it attaches us to a large enterprise. That coupled with the cross-domain mapping allows us to map domains and accurately ID map them across these things. I want to make sure I have enough time for demos. I'm not going to spend too much time other than SMB servers, I get these questions current amount. Do SMB lock supported across servers? We'll leverage Samba in the back end. We've done a ton of work on top of Samba. All of that has been pushed open source, obviously, as well. But NFS locks, for example, is something there is. So SMB locks are shared across all the Samba servers. So if a Samba server goes down, it's maintained by another, so forth. So you don't lose the information, nor are they translated as individual entities. That's another approach. Assimilation is done by inline approach. So when you add a storage volume, we detect you have data on it. We'll say, do you want to assimilate it? And you say yes. We ask you, where do you want to put it in the namespace? And you specify where you want to put it. And you share an existing share. We don't care. You pick your poison. And then it goes through an assimilation process that is inline on demand. So in the background, we assimilate all the metadata. We don't touch the data. We only touch the metadata. So we go out and extract it into DataSphere. We don't wait until the billion files are done. We give access within minutes to the share. And if you access a file that hasn't been assimilated yet, we'll do it inline, and we'll just give you access at that point. It doesn't matter how much you have and so forth. Some filers also have NTFS attributes. We do those currently as a post-process. So you'll do the NTFS side first, and then you'll do the NTFS piece. And that is probably going to change in the future, but that's post-process.
So that when you do your simulation, you identify where you want that, let's say, a storage element NAS box to be set in the namespace. But later on, you're actually moving those files, let's say for performance reasons, wherever you want, perhaps to the cloud and things of that nature.
Data blocks, yes.
The namespace structure doesn't undergo any change at that point.
Correct. The file that you thought was on your old NetApp is now on your ultra-fast
cloud or something,
or in the cloud even, for that matter.
Yeah.
That's the power of that virtualization layer, because you don't have to care anymore. If you want to do that without us, you have to unmount the client, move stuff to the new share, whatever that is, and then remount the new destination on the client. Or you do these symlink approaches, which is pretty much a hack. They don't work well at scale. But I mean, it's very difficult to do this without some kind of technology that abstracts it. The snapshot infrastructure, I spoke about this quite a bit. I'm not sure if I need to cover it too much. What I want to just mention is that we can do incremental copies of the data that's only changed in that snapshot, or we can do a full copy of the actual snapshot. The benefit of our dedupe into the cloud piece is that if you're doing a copy of a full snapshot after the one you just did, the dedupe is already done, and you're not going to copy anything that's already existing in the cloud. Maybe obvious, but they work very well together. The networking piece, we support VLANs, we have virtual networks, we do the NIC bonding, including the link aggregation protocols. We can support all IPv4 storage and export only IPv6 interfaces. So if someone wants to move from one to the other, they can. If they want to do a mix and match, absolutely. No limits. You pick where you want to choose and what you want to export to that. It's been mostly international and government asking for IPv6. The expressions, this is a really interesting piece, and I'm going to demo this in the US. I'm going to skip the slide because I have it all in our UI. What I will mention, and that will be interesting for someone looking at the video, here are the parameters we currently can place and move data on. And this is a list that will be ever expanding, and you'll see in the next time we come in here, it'll be much longer, and we'll have to have 2 slides on it. And it's just how we learn the customer wants to move and place their data, and we're able to expand our system to accommodate. Right? And I'll show you this in an actual objective, so I'm not going to spend time on those, but I'll go through that. And the telemetry we spoke about extensively earlier, I don't think I need to cover this as well, because we spoke about this for like a good 10 minutes earlier. So is there any question on the telemetry piece? Otherwise, I'll move to demo.